Yesterday we did something called composite functions. Today we're going to keep working with composite functions, but we're going to do something called decomposing composite functions, which basically means we're just going to take them back apart to the original f of x and g of x. So to decompose a function h, you want to find two functions with a composition of h, and we'll see what that means in a minute. So look at this first example. It says find two functions f and g such that h of x equals f of g of x. Neither function may be the identity function f of x equals x. That just means you can't cheat and take the easy way out. So when I see this, I know that I have a parent function that's just f of x equals the square root of x. Well, if I had another function that said g of x equals x cubed minus 4, when I got told to do f of g of x, I can see that that would be the square root of x cubed minus 4, which is what I had. So there's my decomposition of this function. All right, let's do another one. We look at h of x, and we know that this is an absolute value function. It's based off the parent function f of x equals absolute value of x. So if we just had another g of x that equaled x squared plus 5, that would be our two functions that when we put them together equaled h of x. So not nearly as tough as it sounded, huh? So now we have x squared minus 2x plus 1. Well, this will take a little more thinking. We can factor this into x minus 1 times x minus 1, which is x minus 1 squared. Well, if we think about our parent function f of x equals x squared, if we just had another function g of x that equaled x minus 1, when we had to do f of g of x, we would put x minus 1 in where x is, and we'd have x minus 1 squared. So that is our decomposed functions. So on the back, on the next page, you'll find a couple of composite function applications, and you can use compositions of functions to solve real-world problems. And so what I'd like for you to do is try and do A, B, and C by yourself, and we'll go over it in class tomorrow, and I'll work through each one of them, but I'd like you to try to do them yourself so you can see how they go.